To enable the cooperation between ground, air, and water-based robotics, a small team in the Department of Electrical and Computer Engineering at the University of New Brunswick started a quest to develop new technology. Our project is both expansive and multidisciplinary. However, our supervisor and pacesetter, Dr. Howard Lee, has assembled a dynamic team of researchers. Liam Paull is a PhD candidate and is working on developing a system for undersea mine countermeasures with multiple autonomous underwater vehicles. Sajid Sahidi is a PhD candidate, and his research interests include robot localization and mapping in a three-dimensional environment. Carl Thibault is a PhD candidate whose passion is unmanned aerial vehicles and is developing smart systems to assist ground personnel in situational awareness. Tyler Edwards is a master's candidate. His background is in mechatronics and is currently developing an unmanned ground vehicle as a research platform. Mustafa Shad is a PhD candidate whose research interests include multi-agent systems and distributed control systems. Arnaldo Sepulveda is a master's candidate whose research area is efficient energy and load management. As an extension to our work, COBRA was invited to compete in the fastest growing student competition in Canada.
The Unmanned Ground Vehicle, or UGV competition, was hosted by Unmanned Systems Canada and was the first of its kind. The challenge posed was to design a ground robot that could navigate a complex, unknown environment from start to finish while identifying targets along the way. The competition consisted of two phases. The first phase was a written proposal that was graded on quality of presentation and innovation of proposed approach. UNB COBRA won first place. The second phase consisted of implementing the proposed algorithms on actual hardware and a final demo in Valcartier, Quebec. Preparations and testing began many months beforehand. In their approach, the COBRA team used Simultaneous Localization and Mapping, or SLAM, to build a map of the environment. Path planning algorithms were developed in a simulation environment and then tested on the real hardware. In order to navigate in the unknown environment, the robot had to be able to avoid obstacles while moving towards the goal and identifying targets. Recognition of targets was done with the Kinect camera designed by Microsoft. This camera gives an image and a corresponding depth map so that locations of targets can be precisely determined. In May 2011, the team embarked on its trip to CFB Valcartier. At the competition site, the details of the approach were presented to the judges. Finally, a test run was done in the unknown environment. The robot was able to successfully move through the environment to the goal while avoiding obstacles and identifying targets. Team COBRA won first place. Team COBRA was crowned the champions at the first ever unmanned ground vehicle competition.
COBRA was also the only team to compete in both the UAV and UGV sections of the competition. To cover a lot of ground quickly, an airplane is the way to go. An electric foam glider was fitted with the necessary sensors to measure its orientation and conduct autonomous flight. The desire is to collect aerial imagery for forest fire protection. Having proven that interfacing with a commercial system was viable, COBRA turned its attention to software. To develop and test control algorithms without the need of actually flying the robot, the Charles River Flight Simulator was modified to provide a virtual environment. Each vehicle will carry a payload of sensors and computer hardware. The heart of the onboard system is an embedded Linux computer the size of only a stick of gum. Software running on the single-board computer controls all the functions in the aircraft. The pilot will control the unmanned aircraft using a graphical user interface such as the one shown here. The operator can enter and upload sets of waypoints that the aircraft will attain in a specified order. This open-source base station control software can control both the simulated model or the real system simultaneously. COBRA is working with Defense Research and Development Canada on underwater mine countermeasures. COBRA has come a long way since its conception in 2009, and the future is bright for this team of skilled and dedicated researchers. Look for more updates for this team in the near future.